can be done on Desmos. One can be, but you can also look at it. So I'll ask, do you want to see one in Desmos or just how you would do it? Or both? So Desmos, the solution, or both? Okay. And then same thing for number 3. Algebraic, Desmos, or both?
Okay.
For number 1, if you were just looking at this without Desmos and you were asked, are these parallel, perpendicular, or neither, you would be looking at the slopes. If they're identical, the exact same, they'd be parallel. Perpendicular, they would have to have the same numbers but flipped. One would have to be positive, one would have to be negative, so they're perpendicular. If there were any other variation of that, it would be neither. Maybe they're both negative, but one's flipped, or they're both positive and one's flipped, or they have different numbers completely. Those would all be neither cases. If we were to graph it, someone tell me those two equations. And the other one. So if we were to graph it, we can look and see that these two, as they're crossing, make that T. It looks like an X if I'm looking straight on, but where it crosses, if I look kind of sideways, they do make that T. They don't just cross in general, so they would be also perpendicular. Okay, for number 3, if we're doing that one algebraically, we have to isolate the absolute value bars. So get rid of 2 by subtracting. And then get rid of 4 by dividing. And at this step, because the absolute value bars are isolated and it equals a negative, we cannot keep solving this. This is no solution. If you were to put in the original, everything all at once, nothing would appear, and that would show you that it's also no solution. Moving forward, make sure that you are trying to use Desmos for as many as possible with the shark bites, as our SOL is slowly approaching. I don't know exactly yet, but keep using Desmos. We will keep practicing using Desmos. Okay. Today, and we're not going to finish everything today, but we're going to start word problems today and continue it next class. Your quiz and tests dates have been moved, but they are still coming up. Quiz is Tuesday. Test is next Thursday. So keep those in mind of next week. Make sure you have these in front of you. As with all word problems, what is the first thing we should be doing as we're reading this?
Highlight the important information.
Yes. Circle, highlight, underline the important information. So I'm going to do that in a second. I will also mention that what's nice about these word problems is we already know how to solve them, because once we get them set up, we're going to be solving by either graphing, substitution, or elimination. So the methods that we already know how to use. Alright, so read this together with me. For example 1, a snack bar sells large and small nachos. Large nachos cost $5 and small packs of nachos cost $3. In one day, the snack bar sold 60 packs of nachos for a total of $220. Let L be the number of large nachos and S be the number of small nachos. Write a system of equations to model this situation and determine how many large and small packs of nachos were sold. What do we think is important there? Large nachos cost 5, small cost 3. What was the next thing we said? $220. 65 nachos. What else? Important, yes, but to find what? Okay, we're looking for that. Anything else important? What about the variables they give you? So if they give you variables, use those, but if they don't, then you can come up with your own. Okay. So to get back in the habit of defining our variables, we're going to write out the two variables that they said that they defined. L equals S equals the number of large nachos and the number of small nachos. We have to be specific. So define your variables first. Then we can start to set up our equations. Remember that we're dealing with a system, so we need two. If we're only given 4 numbers, 3 of the numbers are going to go together. And the other one is going to be in a separate one. Anyone want to take a guess as to how we might set up one? So let's start with some things we know. We know 2 totals, the 220 and the 60. What operation would we be doing to get a total? Adding. So we're going to be adding 2 things together to get both of these totals. So we can say one of the totals is 220. The other is 60. What 2 things are we going to add together to get 220? What do we think? I'm looking for a total of 220. Sorry, did you say something? Okay. If I'm looking for a total of 220, is there something up here I could possibly add together to eventually get there?
$3, $5.
Okay. We are going to add those 2, but we need our variables also. So how could we put all of that together? The other way. 5L plus 3S, but yes. times, so the cost times the number for each 5 times L plus 3 times S would give us 220. But how would we get 60? How would we get the total number of packs? We can't use those numbers again. But what else represents number of packs of nachos? L plus S. So anytime you're given 4 numbers, 3 of them are going to go together. They're going to be related. In this case, money or cost of one pack, the cost of another gave us the total amount. So the money went together. And then the other total, you'll just be adding the variables together. So you don't have to keep that in mind as we go to set up other ones. So then we have a choice of how we want to solve this, by substitution, elimination, or graphing. I will say on your quiz and on your tests, the word problems will be solved by substitution and elimination only. But while we're practicing right now, if you wanted to see graphing, you could do graphing. So which one do we want to see this solved by? Graphing, substitution, elimination?
Elimination.
Okay. So if we want to use elimination, we have to find both the large and small, so it doesn't matter which one we eliminate first. We do, however, have to make one of these the same. We want to eliminate L or S first. Okay, so if we're eliminating S first, these coefficients have to be the same. So I can multiply this equation by 3 to make it the same. I'm going to rewrite both so they're on top of one another. Of the S so it doesn't look like a 5. I don't know how successful I would be at that. Okay, so then now that they're the same, to eliminate, would we add or subtract? Everything so that we have 2L plus 0 equals 40. And solve for L. So L equals 20 what? Is right, but we have to include our labels. We weren't looking for dollars. 20 packs or 20 packs of nachos. Okay. Then we have to go back and find S. So you can put that in any of the 3 equations that we have. I'm going to use this one, L plus S equals 60. So that S equals 40 packs. hardest part about this is setting it up. Once you get it set up, then you just have to choose how are we solving it. Substitution, elimination, graphing. Do we have any questions about that one? Okay, we're going to skip example 2, go on to example 3. Christina went to the mall and bought 5 pairs of earrings and 2 pairs of shoes for $30. Each pair of shoes cost $2 more than 4 times the cost of earrings. Let E be the cost of earrings and S be the cost of a pair of shoes. Write a system of equations to model the situation and determine the cost for a pair of shoes and a pair of earrings. What's important there? What did we see that might be important? So that entire sentence really. Each pair of shoes costs $2 more than 4 times the cost of earrings. What else?
5 pairs of shoes, 2 pairs of shoes.
5 pairs of earrings, 2 pairs of shoes.
$30.
For $30. What else?
E be the cost of earrings and S be the cost of shoes.
And what are we looking for?
Determine the cost for a pair of shoes and a pair of earrings.
So when you go to start defining your own variables, if you're not sure what does this variable represent, you can always look at the question because that's going to tell you. Right, we have our 2 variables, so let's write them out. E is the cost of earrings, S is the cost of a pair of shoes. Make sure you're being specific, don't just write earrings and shoes. One of the equations we set up is going to be just like the one from before where you have the 3 different numbers. Anyone want to take a guess as to how we might set up one of them? Five E plus 2S equals 30. So you always have at least one equation where it's set up like this. You're comparing 2 different things and it equals a total. The other one, it really depends on what you're given. Because of the way this is worded, each pair of shoes costs, so we're talking about the shoes, $2 more than 4 times the cost of earrings. So if I knew the cost of earrings, and I multiplied 4 by it, and I added 2 to it, I would get the cost of shoes. So this is going to be a S equals. But how would I set up that equation? $2 more than 4 times the cost of earrings. How would I write that? So the way this is set up, it's set up really nicely for which method? Substitution, graphing, or elimination? Because we have an S equals. So we're going to take this expression and put it back into S and rewrite it. We have 5e plus 2 times 4e plus 2 equals 3. Then we could distribute combined like terms and solve. So go ahead and start doing that. What is the cost of earrings?
$2.
$2. And then after you find the cost of earrings, go back and find the cost of shoes by putting that 2 back in. And what is the cost of shoes? $10. Say that amount again. $10. Questions on this problem? Any other process? Okay. Go on to example 4. Right, and then let's read that. For example 4, you have $3.70 in dimes and quarters. You have 5 more quarters than dimes. Let D be the number of dimes and Q be the number of quarters. Write a system of equations to model the situation and determine how many dimes and quarters you have. What's important there?
$3.70.
Entire sentence. D is the number of dimes and
Q, number of
and what are we looking for?
how many dimes and quarters you have.
Right, so our two variables D and Q, number of dimes and number of quarters. So let's go ahead and write that. Now they don't give us many numbers for this problem. The 370 is our total worth in dimes and quarters. How would we add to get that total worth? Or what could we add to get that? So D plus Q. So that's part of it. But D and Q represent number of dimes and number of quarters. If I had 5 dimes and 5 quarters, 5 plus 5 would not give me 370. In general or specifically. But how could I add them together to get the worth of 370. So that one more time. This is going to be its own separate equation. Except use decimals. So 0.10d plus 0.25q equals 370. So you have to include the worth of a dime and how many dimes you have, multiply them together to get the total worth of dimes. Same thing for quarters. And then when you add up the total worth of both, you get the 370. Now, let's see. For this other one, you have 5 more quarters than dimes. So if I knew the number of dimes and I added 5 to it, I would get the number of quarters. You kind of have to work that backwards. So this is going to be Q equals 5 plus D. And then this one, like the last one, is set up for substitution really nicely. So we're going to do that. Take this expression and substitute it in where Q is. Distribute and solve that and figure out what that is, what D is. Is that right? 370 minus 125. What is the Seven what? So if you had a problem like this, and let's say you set up the equation, this original one, incorrectly, and maybe switch the Q and the D, as you substitute, you would either not get a whole number, or the number you got, if you put it back in, would not work. You would get something more than 370 or less. So then if I solve for Q, what is Q? Quarters. And if we were to put that back in to the 12 and the 7 in, we would see that that does equal 370. So that would work. Questions on this? So the next part is going to be very repetitive, but it's going to get you in the habit of setting up equations, finding your variables, solving. So we're going to start going through this maze. You're going to need a separate sheet of paper. There are some in the back if you need some. Go ahead and go grab that. Start at start. So read that along with me. At the movie theater, the Clayton family bought 4 fountain drinks and 3 bags of popcorn and paid $22.50. The Hanks family bought 5 fountain drinks and 2 bags of popcorn and paid $23.75. How much is a fountain drink? What's important there? Fountain drinks.
3 bags of popcorn.
What else? There are more of us in the room than the people that are answering. We can all be answering. It'll go a lot faster if we all answer. Say that one more time. So you got the 4 fountain drinks and the 3 bags of popcorn. What else is important? 5 fountain drinks. Second, what did you say? 50, 5 fountain drinks. What else? Okay. What else?
How much is the fountain?
And we're missing one thing. So, we need 2 variables because it doesn't give it to you. You can make it whatever you want. It can be related to the problem. It can just be X and Y. That is completely up to you. So I'm going to use F and P for this one. If you want to use 2 different variables, that's fine. We can look at the question. It says how much is a fountain drink, so we're looking for the cost of both the fountain drink and the popcorn. The cost of both of those. And then because they give us 6 numbers and we're comparing 2 different things, it's going to be set up like how a lot of the other ones were set up. Anyone want to take a guess as to how we might set one up? That would be how we solve it. We have to set up the equations first. 4F plus 3P equals 2250. 4F plus 3P equals 2250. And then the other one? And then you were right. Elimination is a good way to solve this one. Graphing and substitution would give you a lot of decimals and fractions. It can be done, but to avoid that, we'd use elimination. So to eliminate in this one, because we just need to know how much is a fountain drink, we could get rid of popcorn because we don't need it. But to eliminate our p's, they have to be the same. So what could we change that to? Or what could we multiply them by? To change it. Say it again. if we're trying to eliminate p. So multiply the first equation by 2 and the second one by 3. So that way we can start to get the same coefficient and eliminate p.
Double check my math. I'm doing this strictly from memory.
Then as we go to eliminate, because we now have common coefficients, would we add or subtract? So if we subtract, we have negative 7f plus 0 equals negative, do you want to use something to tell me what that number is? As you're solving your word problems, if you get negatives, as long as you get a negative on both sides, it's fine. But if you just end up with one negative, that is bad because we can't have negative answers for our word problems. When we divide, what is the cost of f? And that's in dollars. So now we know which direction we're going to go on the maze. I would show that so that you know which way you're going. Do we have any questions on how we set that up, solved it, anything like that? Alright, let's continue. For this next one, Ryan works at the donut shop where he makes $10.25 per hour. He also works part-time at the school bookstore where he makes $8.75 per hour. If he worked 20 total hours last week and made $196, how many hours did he work at the bookstore? What's important there? I'm going to also highlight that that's about the donut shop. What else? Daniel, did you find something important? Find something important, tell me what it is.
$8.75 an hour.
Okay. What else?
School bookstore.
Okay, so I have the school bookstore with that, yes. What was it?
A total of 20.
Okay, what were you saying?
Yeah, so
The total of 20 hours. Anything else? $196. And we're looking for what?
how many hours did he work at?
Alright, so we need two variables. What do we want to call them? Sure. You want to call them whatever else, that is fine. So in this case, x would be what? It doesn't matter. We can put it to either or. we know we're looking for hours at the bookstore, so that could be X number of hours at the bookstore. I took out all the vowels. So then Y would be
Hours at the gym.
correct. So we have our variables. Now we need our equations. Remember that this one has 4 numbers, so there's a specific type of way to set that up. How would we set either equation up? We have totals. What are they?
$10.25.
So this isn't, these two aren't your totals. The 1025 and 875.
196.
And
20.
20. So we know our 2 equations are going to equal those. How could we fit the other numbers into the equations? How could we fit our variables into the equations? Equals which of these? Now, if you use different variables or you switch these, your variables have to match your numbers. So whatever donut shop is for you, that number and that variable have to go together. How would we set up the other one?
E plus D.
Whatever the 2 variables are, yes. In my case, it would be X plus Y. If you use D and D, that's fine. Do we want to solve this by graphing, substitution, or elimination?
Substitution.
If we're solving by substitution, we're looking for the hours worked at the bookstore, which in my case is X. If I were to solve for Y and substitute that back in, then I'd be left with just X's. So I'm going to solve this for Y, this equation, for Y. Get get Y by itself, get rid of the X. And then take that equation and substitute it back into the other one where Y is. We have 1025 times 20 minus X plus 875X equals 196. And multiply. Tell me what this number is when you get it. When you combine like terms, tell me what that is. the number of hours worked?
Yes. Go ahead, Kristen.
Alright, let's do this next one. Do we have any questions about the last one we did? At the gym, Kara burns 12 calories per minute on the elliptical and 10 calories per minute on the treadmill. If she worked out for 1 hour and burned 676 calories, how many minutes did she spend on the elliptical? What's important there? Say that again. 12 calories. I'm going to say for the elliptical. 10 calories on the treadmill. Brian, find something else that's important.
If she worked out for 1 hour and burned 676 calories.
So both of those things, yes. 1 hour, 676 calories.
How long did she spend on the elliptical?
How many minutes did she spend on the elliptical? Alright, so we need two variables. What do we want to call them? E and T. I would capitalize the T so you don't confuse it for a plus as you're writing, but E and T work. What do E and T represent? Dragging a cart or something. Look at our question. How many minutes did she spend on the elliptical? So how would we define our variables? Number of minutes on each, yep. So we have our variables. We again have four numbers, so they're going to be set up very similarly to the last problem we did. How would we set up these two equations? What are the two totals here? I heard one of those is 676, and what else? So this 1 hour, it doesn't say to change it to minutes, but everything is measured in minutes. So you have to know to change it to minutes. So these are our two totals. Where would the other two numbers go? How would we set that up? Or equals which one? Yes. So 12e plus 10t equals 676. And then what equals 60? Equals t. Do we want to solve this one by substitution, graphing, or elimination? Just so you can see how it's done, this will not be done on the quiz or on the test. So if, and you could also do this while you're practicing, if, let's say there were a question that's on the word problems that you have to do by graphing, this is how you do it, but there's not, so this is just for practice only. You would have to have variables that are x and y. Other variables won't work. It does not matter which one you make x, which one you make y. You just have to be consistent. If you make one e in x, the other e can't be a y. You have to go through the same. And then both equations, since we're doing this in a calculator, but remember, again, this would not happen on the quiz or the test, and this solving systems by graphing is no calculator. We'd have to solve both equations for y, get rid of x. So that first equation would be y equals 60 minus x. The second one, I would be subtracting 12x. So we have 10y equals 676 minus 12x. And divide everything by 10. You're going to have decimals. That's okay. So 76.6 and 1.2. 67.6, I don't think that's the word. Anyway. You're going to reset your calculator, second plus 712. And then we're going to go into our y equals. And we're going to type in both of those equations, 60 minus x and 67.6 minus 1.2x. If you were practicing like on Delta Math and you were using Desmos, you would not need to solve for x or solve for y at all. You would still need the variables x and y, but you would just put it in as is. Once you have those two in, hit graph. Our y-intercepts are like at 60 and 67, so we'll have to zoom out. So you do one or two things. Go into zoom and either hit zoom out and hit enter, or you can go all the way down to zoom fit. This usually fits it, but sometimes you still have to zoom out. So the zoom fit, you can see the lines, but you can't see where they cross. You really need to see where they cross. So we'll have to zoom out again. So zoom out and hit enter. And now I can see where they cross. Sometimes if it's off to the edge, you may have to zoom out one more time to make sure that the intersection is in the screen, but this may work. We'll see. I can't read these lines. I have no idea what this is counting by, so I'm going to go into my second trace, into intersect, and hit enter 3 times. And it'll tell me what that intersection point is, 3822. Notice that those answers are up here. We have to know which one we're solving for, though. So elliptical, we make x, e was x. So that would be 38 minutes on the elliptical. The next one is like the last example 4, but this only has one answer choice, so we don't have to solve it. If later you want to go back and solve that in your own time, feel free to do so. We're also done for today. We've done a lot. So the next class, after the short guide, we will continue this, and then you'll have more time to practice. So for the remainder of class, you can be working on, you can keep going on this, but just know that we are also going to keep going on this next class. You can work on does math. Let's do this Friday on this word problems. You can work on does math from last Friday, elimination. Does math from 2 Fridays ago, graphing and substitution. If you have missing tests, you can work on them. You can work on retake work. Be working on something for the remainder of class. No phones yet, but you can grab an iPad to work on any of those. Reminder that Wednesday is the last day to